Welcome to today's episode of Daily AI Brief. In our fast changing technology landscape, AI continues to push the boundaries of what's possible. From parameter scaling methods that enhance reasoning capabilities to security solutions that revolutionize online safety, the impact of AI is undeniable. Our exploration today spans multiple advancements, revealing how innovations in AI are shaping industries like software development, cybersecurity, and scientific research. Stay tuned as we dive into the latest breakthroughs and their implications. Advancements in AI models have often focused on building larger architectures or increasing dataset size. However, recent progress has introduced a new direction: test time scaling. This novel approach enhances AI model reasoning abilities by dynamically adjusting their inference processes. Test time scaling operates across three dimensions: context scaling, which adjusts the scope of information considered by the AI; batch scaling, which influences the number of data batches processed; and turn scaling, which modulates the iterative interactions during tasks. This multidimensional approach bridges the gap between resource constraints and model flexibility. Performance benchmarks such as IOI, intermediate overlapping inference, IMO, interactive model optimization, and CPHO, cognitive problem handling optimization, have recorded significant improvements, demonstrating the practical efficacy of test time scaling. Interestingly, smaller models outfitted with this scaling can outperform their larger counterparts. This is particularly insightful as it showcases the potential for more efficient resource use while maintaining high performance. The integration of human-in-the-loop feedback within this framework adds another layer of sophistication. By iteratively incorporating expert insights, the model refines its outputs, which enhances its adaptability and reasoning beyond automated algorithms alone. This method not only improves accuracy, but also provides a dynamic mechanism for real-time refinement, allowing models to adjust based on new data or tasks. Yet there are challenges. The effectiveness of test time scaling can vary significantly by domain, and finding the right balance between training time and test time adjustments remains an open question. Relying heavily on specific benchmarks for validation also carries risks, as these selected tests might not cover the full variability encountered in real-world applications. Moreover, the ambitious application of multidimensional scaling may encounter limitations related to scalability, especially in high-complexity domains or with very large datasets. For those keen to explore the practical applications of these advancements, several resources are available. Detailed methods can be explored in published papers and open-source GitHub repositories that outline technical strategies for implementing test time scaling. Additionally, Adeline's blog offers insightful demos on reasoning improvement techniques, providing a hands-on introduction to these methodologies. Test time scaling paves the way for dynamic AI models capable of tackling diverse problems while requiring minimal retraining. This holds transformative potential for the industry, marking a shift towards more adaptive and resource-effective AI implementations. It emphasizes the importance of not merely increasing model size, but enhancing existing capabilities through smarter inference strategies. In sectors where quick adaptation and robust problem-solving are paramount, such as healthcare and autonomous systems, this approach could significantly accelerate progress and deployment of AI solutions. OpenAI and Anthropic have unveiled their latest AI models, GPT 5.3 Codex and Claude Opus 4.6, with a promising focus on advancing enterprise functionalities. Released on February 5, 2026, these models aim to significantly enhance operational capabilities, particularly in software development and analytical tasks. GPT 5.3 Codex, enhancing software development. GPT 5.3 Codex stands out by improving software development, achieving a notable 25% increase in speed over its predecessor, GPT 5.2. This improvement is critical for enterprises handling vast and complex software projects, allowing developers to iterate more efficiently across millions of tokens. The model is designed as a computer-using agent capable of completing end-to-end software development tasks, fundamentally reshaping how coding and development are approached. Performance benchmarks indicate superior task handling with a score of 77.3% in Terminal Bench 2.0, marking it as a leading choice for software engineering excellence. Claude Opus 4.6 Advanced Analytical Features. Conversely, Claude Opus 4.6 introduces compelling features tailored towards analytical and strategic processes. The most remarkable of these is the 1 million token context window, albeit still in beta, which allows for processing extensive datasets and is ideally suited for handling intricate codebases and significant text processing needs. Coupled with its agent teams architecture, Claude Opus promotes enhanced parallel collaboration, enabling diverse AI agents to work together on complex issues seamlessly. This model's prowess is highlighted by its discovery of over 500 severe security flaws in open-source libraries, showcasing its unparalleled ability to identify vulnerabilities without specialized prompting. Integration with business tools. A crucial strategic move is the integration of these models with existing business platforms like Microsoft 365. This integration allows for seamless handling of documents, spreadsheets, and presentations, thus pushing AI deeper into business operations. With Claude Opus 4.6's API offering adaptive thinking for complex task management, businesses can harness these tools to revolutionize their workflows. However, the practical efficiency and stability of features like the 1 million token context need further real-world validation. Evaluating performance and potential. To experience the capabilities of these groundbreaking models, enterprises are encouraged to access GPT 5.3 Codex via OpenAI's API and explore Claude's integration within Microsoft 365 environments. Conducting performance benchmarks on various coding and analytics tasks will provide insights into their distinct strengths and areas for improvement. Challenges and future prospects. Despite their advances, there are practical challenges and trade-offs involved. The beta context window in Claude Opus necessitates rigorous testing to confirm stability, and the effectiveness of agent teams in enhancing productivity over solo agents remains to be fully assessed. Additionally, the model's real-world performance under varying operational scenarios poses questions about broader applicability and potential limitations within enterprise contexts. These model releases signify substantial progress in AI's ability to enhance business efficiency and may set the standard for future integrations. As new benchmarks emerge and AI tools continue to evolve, the landscape of enterprise AI will likely undergo significant transformation, driven by models like GPT 5.3 Codex and Claude Opus 4.6. Microsoft's latest update to Visual Studio Code brings powerful enhancements to multi-agent system development. The release of Visual Studio Code 1.107 integrates features that dramatically improve multi-agent operations, focusing on augmenting coding collaboration. The core of this update is the introduction of multi-agent orchestration, a feature allowing simultaneous coordination among various agent tools. This enhancement lets developers harness the capabilities of GitHub Copilot in conjunction with custom agents, substantially accelerating software development tasks. At the heart of these operations is Agent HQ, a centralized management hub designed for comprehensive coordination of multiple agents, effectively streamlining communication and task allocation. Model Context Protocol. The implementation of the Model Context Protocol, MCP, is a cornerstone of this update. MCP facilitates seamless connections to external services, enabling agents to handle complex projects with fewer interruptions. Traditionally, context switching has been a significant barrier to maintaining productivity in development cycles. By minimizing these disruptions, MCP supports a more fluid workflow, allowing developers to focus on coding rather than tool integration. Practical usage insights. For practitioners eager to harness these improvements, downloading Visual Studio Code 1.107 is the first step. The integration of the Copilot Studio extension within the IDE provides direct management features for agents, streamlining real-time task orchestration. Agent HQ can be employed for enhancing coordination among teams, offering a practical way to explore these enhancements in real-world scenarios. Metrics and efficiency. Although specific quantitative benchmarks regarding task distribution efficiency have not yet been published, anecdotal evidence suggests a noticeable reduction in development cycle times. This aligns with the proposed goal of reducing context switching and enhancing task distribution, potentially leading to shorter project timelines and accelerated deployments. Considerations and challenges. Despite these promising advancements, challenges remain. Compatibility issues with existing extensions, as well as a potential learning curve for developers new to multi-agent systems, are a few hurdles that organizations may face. The need to adapt alongside new tools can introduce resistance, particularly in environments where traditional practices predominate. Conclusion. The enhancements offered by Visual Studio Code 1.107 position it as a pioneering tool in modern development practices. By merging traditional methods with automated processes, it fosters optimal productivity. As development teams explore these new capabilities, the transition towards a more collaborative, agent-driven approach in coding is likely to redefine industry standards, offering both increased efficiency and innovative ways to tackle complex programming challenges. Google has made a significant move in the developer ecosystem with the introduction of the Developer Knowledge API and the MCP server, unveiled on February 4, 2026. This public preview aims to redefine how developers access and interact with technical documentation, enabling more efficient development workflows across platforms such as Firebase, Android, and Google Cloud. The Developer Knowledge API makes documentation retrieval both dynamic and accessible. It delivers content in Markdown format, ensuring compatibility with various development tools and platforms. One of the standout features of this API is its commitment to content freshness. Documentation is re-indexed and updated within 24 hours of any change. For developers, this guarantees that they have access to the most current resources, which is crucial for implementing rapid iterations and adjustments in project workflows. In tandem, the integration of the Model Context Protocol (MCP) server opens up new possibilities for AI assistance in the development process. The MCP, adopted from Anthropic's standard introduced in November 2024, facilitates AI-driven functionalities such as offering contextual implementation guidance and performing comparative analysis across different documentation streams. By connecting AI systems with these vast repositories of technical knowledge, the MCP server elevates the capabilities of AI tools, making them more responsive and intelligent. From a technical standpoint, the infrastructure supporting these new tools is robust. By maintaining compatibility with major AI platforms, the MCP server ensures that the integration of AI into existing development environments is seamless. This interoperability significantly reduces the time and complexity associated with integration processes. Benchmarks indicate a noteworthy reduction in time to implementation for many developers. For developers eager to leverage these advancements, practical steps involve joining the public API preview. By doing so, they can experiment with the API's documentation retrieval features, discover detailed implementation guidelines from resources such as the Google Developers blog, and explore integrating MCP servers with current AI frameworks. This experimentation can provide tangible insights into the potential productivity boosts AI-driven documentation can offer. Despite its promising functionalities, there are trade-offs and challenges to consider. Security is a primary concern. The MCP's open interface might expose systems to vulnerabilities, including credential theft. Moreover, while Google's integration sets a new standard, the broader adoption of MCP by external platforms is still uncertain, which could limit these benefits to Google's ecosystem alone. Compatibility issues also pose a potential hurdle as AI tools vary in architecture, which might complicate seamless integration. In summary, Google's launch of the Developer Knowledge API and MCP server represents a forward-thinking shift towards more streamlined and intelligent development processes. By enhancing accessibility and updating frequencies, these tools could significantly improve developer productivity and set new standards in the industry. However, the challenges in security and broader adoption need careful management to fully realize these potential benefits. Anthropic's latest advancement with Claude Opus 4.6 is a significant stride in the realm of cybersecurity, making headlines by identifying over 500 high-severity vulnerabilities within open-source libraries. This accomplishment underscores the profound capabilities of artificial intelligence, particularly in automated vulnerability detection, a domain often plagued by challenging complexities and dynamic threat environments. The Claude Opus 4.6 model utilizes sophisticated reasoning skills to navigate and scrutinize codebases, seeking out vulnerabilities such as system crash exploits and memory corruption issues. This model's ability to exceed traditional security tools is noteworthy, as it operates without the constraints of predefined detection patterns that often limit conventional approaches. These patterns are typically based on past vulnerabilities and may overlook novel or evolved threats. Quantitatively, the model's performance is impressive, having detected over 500 hidden high-severity vulnerabilities. This figure not only highlights the scale of existing potential threats in widespread use, but also showcases Claude's ability to rapidly and accurately identify flaws at groundbreaking speeds, a task that traditional methods struggle to match without extensive human input and oversight. A technical drill down reveals that Claude Opus 4.6 doesn't require specialized prompting. It autonomously parses through comprehensive stacks of mature open-source codebases, identifying potential weak points that previously escaped detection. This capability emphasizes the model's robustness in facing cybersecurity challenges on complex digital infrastructures, making it an indispensable tool in proactive security strategizing. Despite these advancements, integrating such cutting-edge AI systems into existing cybersecurity infrastructures poses challenges. Organizations may face difficulties aligning Claude's analytical processes with their current frameworks, necessitating updates or overhauls to effectively accommodate AI-driven insights. Additionally, while Anthropic has implemented strong security controls to prevent misuse, the risks of dependency on AI without human oversight remain. For cybersecurity professionals seeking to harness these capabilities, a pragmatic approach involves engaging with the demo links available on Anthropic's official site. This allows developers to explore Claude Opus 4.6's functionalities firsthand and perform comparative analyses against traditional vulnerability detection methodologies. By doing so, professionals can better appreciate the AI's strengths and limitations within their specific contexts. Beyond vulnerability detection, Claude Opus 4.6's advancements indicate a broader shift towards AI's growing role in defining cybersecurity measures that are not just reactive, but increasingly preemptive. The technology has the potential to revolutionize defensive measures, highlighting possible paths for future research and development in AI-assisted security. As digital threats continue to evolve, Anthropic's contributions with Claude serve as a crucial reminder of the necessity for ongoing innovation and adaptation in cybersecurity practices. Associa, a leading company in community management, has partnered with AWS to revolutionize document classification. This partnership utilizes Amazon Nova Pro on Amazon Bedrock to deliver an innovative AI-powered system that achieves a remarkable 95% classification accuracy at an average cost of just 0.55 cents per document processed. This technological integration represents a significant advancement, offering both efficiency and precision in document management tasks. The cornerstone of this system is its use of generative AI capabilities built upon the robust infrastructure of Amazon Bedrock. This allows for scalable deployment, ensuring the system can handle increased document volumes without compromising performance. By substantially reducing manual processing efforts, the integration has seamlessly fit into existing workflows, promoting operational efficiency and leading to notable reductions in labor costs. Andrew Brock, Associa's CIO, has highlighted these improvements, emphasizing the transformative impact of AI across the company's operations. One of the critical components of the system is its ability to adapt to various document types and formats, which is crucial for enterprises handling diverse datasets. The reliance on generative AI techniques has facilitated improved classification accuracy, setting a high benchmark in document management solutions. However, the system's long-term scalability, particularly across diverse document types, remains untested. Additionally, the specific impacts on overall operational efficiencies are yet to be fully evaluated over time, suggesting that ongoing assessments will be necessary to validate sustained benefits. A notable trade-off exists in the choice of Amazon Nova Pro over other competing models, such as Anthropic's Claude Sonnet 4. While the current model offers impressive results, understanding the specific advantages and limitations in various scenarios will be crucial for maximizing its application. Those interested in exploring similar AI-driven solutions can dive into the AWS blog on the Gen AI IDP Accelerator for detailed implementation insights. Additionally, testing the Amazon Nova Pro API may provide practical exposure to its document classification capabilities. Associa's successful collaboration with AWS sets a compelling precedent for other enterprises contemplating AI adoption. It underscores the potential of AI not only to drive down costs, but also to enhance accuracy and efficiency in document management processes. This case illustrates AI's transformative capacity, potentially influencing strategic technology investment decisions across similar companies. Moreover, it lays the groundwork for future innovations as generative AI continues to evolve, promising further advancements in business applications. The scalability concerns and unverified long-term performance of the system highlight areas for future development, suggesting that ongoing technological enhancements could bolster the system's capabilities in handling the demanding document management needs of large organizations. With the increasing integration of AI, businesses are likely to see expanded roles for AI technologies in transforming traditional operations and unlocking new efficiencies. Google AI, in collaboration with Peking University, has unveiled a transformative tool called PaperBanana, specifically designed to automate the creation of publication-ready visuals for researchers and academics. This innovative framework is the result of integrating advanced artificial intelligence techniques, employing 5 specialized AI agents that streamline content planning, style rendering, and iterative refinement. These agents work in concert to minimize the traditionally labor-intensive task of academic illustration, presenting a potentially revolutionary approach to scientific communication. One of the key strengths of PaperBanana is its use of iterative refinement through self-critique, which allows it to improve upon initial designs by utilizing feedback loops to enhance the generated visuals systematically. Despite this capability, the tool's content fidelity, the degree to which the AI-generated visuals accurately reflect the intended content, is only at 45.8%. This suggests that while PaperBanana has significant potential, it might sometimes introduce inaccuracies, particularly in complex illustrations, where human expertise traditionally plays a crucial role in capturing nuanced details. The framework was rigorously evaluated against 292 test cases derived from NeurIP's 2025 publications, where it outperformed leading baselines across several metrics: faithfulness, conciseness, readability, and aesthetics. It was favorably received by human reviewers in 73% of diagram cases, showcasing its ability to produce visually appealing and concise content. However, this also highlights a potential trade-off: the risk of researchers becoming overly reliant on AI tools, potentially at the expense of developing traditional illustration skills. To harness PaperBanana's capabilities, developers and researchers are encouraged to visit the official website for demo usage, which provides a gateway to exploring how this tool can be integrated into existing academic workflows. The framework offers APIs for seamless integration, facilitating ease of adoption across academic environments that demand high-quality visual aids. PaperBanana not only represents a significant leap forward in academic communication, but also challenges the entrenched methodologies of illustration, which often require specialized skills with tools like TIX or Python PPTX. By providing an AI-driven alternative, PaperBanana enhances efficiency and opens the door to broader acceptance and reliance on automated visual aids within academia. Nevertheless, further iterations and user feedback will be essential to address the current limitations, particularly the relatively low content fidelity. The ongoing development could eventually expand PaperBanana's applications beyond traditional academic domains, potentially affecting sectors where visual communication is crucial. As AI-driven tools like PaperBanana continue to evolve, the academic community must consider the balance between embracing technological advancements and preserving the integrity and creativity of manual illustration practices. NVIDIA has unveiled its cutting-edge NVFP4 technology, a 4-bit floating point precision format meticulously designed to enhance AI training by significantly boosting speed and reducing energy consumption. As AI models grow increasingly complex, the pressure on computational resources and energy costs amplifies. NVFP4 strategically addresses these challenges, promising improved speed and efficiency while maintaining a level of precision comparable to the more traditional BF16 format. The NVFP4 format's core advantage lies in its ability to utilize multi-level scaling, married with low-precision computations that allow for quicker processing times without sacrificing critical task accuracy. This breakthrough could be monumental for industries relying heavily on AI, such as healthcare, automotive, and finance, where real-time data processing and model updates are pivotal. To test the feasibility and performance of NVFP4, NVIDIA deployed its latest technology within the Blackwell Ultra GPUs and ran them through the rigorous MLPerf training v5.1 suite. Astonishingly, these GPUs achieved top marks across all 7 benchmark tasks, revealing NVFP4's potential to reshape AI processing. These benchmarks highlighted improvements in both speed and energy efficiency over existing formats such as FP8 and BF16. Moreover, NVFP4's implementation showed a marked reduction in memory usage, an essential feature given the limited memory resources available in many computing environments. However, while the technical specifications sound promising, there are trade-offs and uncertainties that need attention. As a proprietary technology, NVFP4 may face adoption barriers, particularly given its potential incompatibility with existing AI frameworks that are heavily entrenched in the industry. Furthermore, its long-term applicability across various AI applications is still under scrutiny. There is a speculative concern about whether this technology will harmonize across different platforms or how it will perform under diverse, real-world pressures outside benchmarked settings. For developers eager to harness this technology, NVIDIA provides comprehensive resources to facilitate the integration of NVFP4 into existing projects. Their technical blog offers a wealth of knowledge on optimization techniques, allowing developers to carefully compare NVFP4 functionality against more conventional formats. Engaging with these resources can empower developers to make data-driven decisions on whether NVFP4 is an appropriate match for their specific AI requirements. NVIDIA's NVFP4 doesn't just improve performance metrics, it could ultimately set a new standard for precision in AI training. By maximizing efficiency while minimizing memory and energy consumption, NVFP4 exemplifies NVIDIA's role as an innovation leader. As companies and developers globally strive for more sustainable AI applications, technologies like NVFP4 pave the way for greater computational efficacy, facilitating more extensive, economically viable AI adoption. While the journey of NVFP4's industry acceptance unfolds, its initial impact exemplifies the potential for transformative strides in AI model development and deployment. OpenScholar has introduced a revolutionary AI tool designed to redefine the literature review process in academic research. By leveraging retrieval-augmented generation (RAG) methods, OpenScholar utilizes a database of 45 million open-access papers to enhance citation accuracy, minimizing AI-related pitfalls like citation hallucinations, a common issue plaguing many traditional models. The tool's performance against benchmarks like ScholarQBench highlights its effectiveness. In testing over 2,967 expert queries, OpenScholar outperformed models such as GPT-4o by 5% and PaperQA2 by 7% regarding correctness. Existing models often showed hallucination rates between 78 to 90%, whereas OpenScholar achieved citation accuracy comparable to human experts, setting a new standard in AI-driven literature reviews. Moreover, OpenScholar's open-source nature allows for extensive user customization and integration into existing workflows. Users can deploy the tool directly onto their systems, enhancing transparency and reducing costs associated with literature synthesis. This capability facilitates personalized literature reviews tailored to specific research needs without having to navigate complex licensing or usage fees typical in proprietary software. Despite these advances, there are notable limitations. The reliance on a curated database of open-access materials might exclude significant studies trapped behind paywalls, potentially resulting in a lack of comprehensiveness in some niche research areas. Human oversight remains essential, as even with reduced hallucination rates, the tool may still produce inaccuracies that require expert intervention. Academics eager to explore OpenScholar's capabilities can find setup instructions on its GitHub repository, which guides users through the installation and demonstrates integration options via available API documentation. This approach not only democratizes access, but also provides flexibility for integrating OpenScholar within various research management systems. The implications of OpenScholar's development are considerable. By expediting the literature review process, researchers can allocate more time to critical thinking and data analysis, potentially driving faster scientific advancements. The tool's efficiency may also encourage inclusion in academic curricula and institutional workflows, promoting a cultural shift toward AI-enhanced research methodologies. OpenScholar is poised to influence academic standards, elevating reliance on AI tools for literature synthesis. It might trigger competitive advancements in the field, urging other models to improve citation accuracy and relevance, thus fostering a race towards innovation in information retrieval technologies. The potential to integrate OpenScholar into publishing frameworks could also streamline processes for grant applications, reducing administrative burdens and ushering in a new era of research and discovery. The ongoing development and community-driven support suggest promising prospects for further refining and expanding the tool's capabilities to meet diverse academic needs effectively. As we conclude today's episode, it's clear that AI is reshaping every aspect of our technological lives, from enhancing software development with test-time scaling to securing systems through advanced AI models. The impact is vast and profound. With new tools like NVIDIA's NVFP4 and Google's PaperBanana transforming efficiency and creativity, the future of AI looks promising. Thank you for tuning in to Daily AI Brief. We hope today's insights equipped you with valuable knowledge to navigate the evolving AI landscape. Stay curious and join us again tomorrow for more on the innovations driving our world.